In part 2 of this lesson, I'll show you how to use the exponential density function. The exponential density function, which was already derived in one of our videos, looks like this. And the question reads, suppose the average waiting time at a bank, let's say, is 15 minutes. What is the probability of being served in less than 10 minutes time? And what is the probability of waiting more than 15 minutes? We've already set our average to be 15, so mu is equal to 15, and so I can substitute 15 into where I see mu, into here, where I have f of t is equal to e to the power of negative t over 15, and this expression is over 15. To find the answer to part A, what we have to do is take the integral between 0 and 10, because it's less than 10 minutes, so anything between 0 and 10. And our function, of course, is e to the power of negative t over 15, and that's over 15 with respect to t, so dt. Integrating this isn't hard. In fact, I can start by taking the constant 1 over 15 outside of the integral, where I end up with 1 over 15 times the integral between 0 and 10, e to the power of negative t over 15 dt. I'll do a simple substitution here where I set this part, the exponent of e, equal to u, and take the derivative with respect to t. So I have du is equal to negative 1 over 15 dt. Solving for dt, so I can replace this with that, I end up with negative 15 du is equal to dt. So I'm going to replace this with u and this with negative 15 du. I have 1 over 15, the integral between 0 and 10, e to the power of u, remember this was set to u, and dt is negative 15 du. This is being multiplied. I can pull out this negative 15, and if I do pull it out, it will cancel out with this 15, where I end up with negative times the integral between 0 and 10, e to the power of u du. Taking the integral of e to the power of u is easy. In fact, it's the same thing. So taking the integral of this, I end up with negative e to the power of u, which is negative t over 15, e to the power of negative t over 15, and we don't need a constant because this is a definite integral. I'll evaluate this at 10 and 0. Evaluating it at 10, I get negative e to the power of negative 10 over 15. And then I'll evaluate this at 0, where I have minus e to the power of negative 0, which is e to the power of 0. I'll use my calculator. E to the power of negative 10 over 15 minus e to the power of 0. And then whatever that is, I multiply by negative, so I end up with 0.486. That can be interpreted as a percentage, and it should. So 48.6% will be the probability of being served in less than 10 minutes. In part B, we're asked, what is the probability of waiting more than 15 minutes? So this time, our integral will change slightly. We'll have 15 to infinity. This is an improper integral, so we have to take the limit at some point. And once again, we have e to the power of negative t over 15. I'll use the same playbook as in part A and skip a few steps. So we ended off with this as our integral. We had negative e to the power of negative t over 15. And this time we have to evaluate this at infinity and 15. Although you can't evaluate a function at infinity. It's impossible. So I'll replace this infinity with an arbitrary constant. Let's call it w. It can be any letter. And what I'll do is take the limit as t approaches w. And remember, w is set to infinity. So we have negative e to the power of negative w over 15. And then whatever that is equal to, I'll subtract it by negative e to the power of, substituting 15, we get negative 15 over 15. Let's go ahead and find the limit as t approaches w. Well, if I put a very, very large number into w, and it's a negative number, then e to the power of a very large negative number gives us a number very close to 0. So we have 0 times negative, that's 0, minus e to the power of negative 15 over 15, which is negative 1. So putting that into our calculator, negative bracket negative e to the power of negative 1 gives us 0.3673. 0.3673, and as a percentage, that's 36.7%. So there's a 36.7% of waiting more than 15 minutes. The question underneath says, why isn't the answer to part B 50%? Because the average waiting time is 15, and we want to know the probability of waiting more than 15 minutes. To answer that, keep in mind that some people wait really long, and that pushes the average wait time upwards. And this is the reason why it's not at 50%. And there you have it. That is how to use exponential density functions.